Let's have an introduce of Handheld Partial Discharge Tester. Handheld Partial Discharge Tester mainly used for checking the partial discharge level of switchgear, transformer, generator, GIS etc. The unit included the main host and multiple different sensors. And every piece of sensors have their own different uses. Firstly, for the main host part. The main host itself comes with two fixed sensors at the top side. One is an ultrasonic sensor. The other one is a transient ground voltage sensor, referred to as TEV method. The left side is ultrasound method. You can directly use the top sensor for measurement without using any external sensor. External sensors can also be used for more accurate measurements. After introducing the host, let's take a look at the ways in which each sensor is used. Firstly, this biggest sensor. It is for testing the GIS. There will be a dedicated partial discharge detection port on the GIS tank. Or perhaps a coupling agent needs to be applied at the corners. Then press the curved surface of the sensor tightly against the GIS. The small one next to it is a magnetic sensor, mainly used for partial discharge detection of transformers, generators, and motors. When in use, it comes with its own magnetic attraction. It needs to be attached to the casing of transformers, generators, or electric motors. The circular ring next to it is for cable partial discharge detection. Cable partial discharge testing requires a circular ring to be placed on the grounding wire of the cable and conduct testing when the cable is on live. The long foldable sensor is a flexible sensor, used for testing in switchgear and hard-to-reach areas. There is also a pair of headphones next to it. During testing, headphones can be used to monitor the local partial discharge level. The last one is wave condenser. The wave condenser is used to detect the discharge situation of overhead power lines. Directly align it with the overhead line that needs to be inspected during use. And there will be specialized connecting wires at the bottom to connect with the main host. All sensors have their own dedicated connection cables to connect to the main host. Now let's take a look at using a handheld partial discharge tester to measure partial discharge of switchgear in actual use. After turning on the tester, it will automatically activate the two built-in sensors at the top side. In the upper left corner of the tester. After turning on the test, TEV is displayed in the upper left corner, which is the transient ground voltage method. Click on the bottom left corner to switch. You can see that it has now become AA, which is the ultrasound method. This operation can switch between the two built-in sensors. If we use TEV now, just need to align the top with the switchgear. You can see that the current partial discharge level is about 8 dB. At this point, turn on the partial discharge source of the cabinet. After opening the partial discharge source, it can be seen that the discharge capacity has significantly increased. At this time, data can be saved. In the saved data, the discharge amount and pulse frequency can be seen. Now switch to ultrasound model and test again. This is the ultrasound method. Let's demonstrate it again. Now let's demonstrate the usage of AE sensors. When in use, a dedicated connection cable is required, which is the AE connection cable. Connect to the bottom of the main host. Just insert directly. After successful insertion, it needs to be attached to the cabinet. Conduct the test too. After connected to the sensor, the upper part of the instrument will automatically switch to the current sensor mode being AE. You can see that it has already been attached to the cabinet. Turn on the discharge switch. There will be significant discharge of electricity. The data can be saved inside the tester. Stop. The usage method of other sensors is the same as AE. All require connecting cables to the host.